So again, that's all we're doing today is distance and midpoint. So given 2 points, what's the shortest distance between them? What's the halfway point? I'll tell you the theory first, then we'll actually do some calculations. Theory comes from looking at the horizontal distance and the vertical distance, which we know makes a right angle. Just jumping back to the last unit, where did we see this idea? What did we talk about that we drew this little triangle and talked something about horizontal and vertical? Rise over run, and what was that equal to? Slope. That's what's coming in this unit. We're going to go back to the idea of slope in a second. Okay, and if I know this distance, which is just an x-coordinate, and I know this distance, which is just going to be a y-coordinate, how do I find the third distance? So what's the formula? But I don't have an a or a b on here. So x squared plus y squared equals, that's a d for distance, d squared. D for distance. And if I wanted to get the d by itself, what would I do to get rid of the squared? So what's the opposite of squaring something? Square root. So this would end up being the square root of x squared plus y squared. But A has its own x and its own y, and B has a different x and a different y. So what's the value that I'm putting in here? Is it the x of A or the x of B or a completely different x? Well, what are the coordinates of A? 3 and 7. And what are the coordinates of B? Offer of -3 and 3. Okay, so what am I putting in for that bottom distance? Well, how many units is it? How many units on the bottom distance? Count the number of squares. There's 6. Well, where does that come from? That's just the difference in the x values. So if I take -3 and I -3, how many units do I get? 6. What happened to the negative? Well, it's a distance. So does it matter if it's -6? No. So here's where the scary part of the formula is going to come from, and I don't want you to freak out. I'll explain it in a second. What we're doing is taking the difference of the x's. What the heck is that? Well, those are just little subscripts, and that just means the second x minus the first x. And what does that mean? The x-coordinate of B minus the x-coordinate of A. The subscripts are just referring to the two different x values. We're going to do the same thing with the y's, is we're going to take y2 minus y1 and square it. So just making some notes, what this means is the second y-coordinate, or sorry, x-coordinate. And x1 means the first x-coordinate. And the only reason we use those little subscripts is because there's two x-coordinates. So it's just to distinguish between which one. What do you think y2 means? The second y-coordinate. And y1 means the first y-coordinate. Well, which one's first? Is it A or B? And here's the fun part, it doesn't matter. As long as you take the same x and y and call them the first, and you take the second x and y and call them the second, it doesn't matter which is A or B, and I'll show you what I mean by that in a second. What you need to add to your card and to your box in red pen is this is what's called the distance formula. And we call it the square root of x2 minus x1 squared plus y2 minus y1 squared. It's just a fancy version of Pythagorean theorem. You can. This is just doing it in one step instead of 3. Wait till you see the example. It's up on my wall. It's the very first formula by the door, so the first yellow sheet, it will always be up there, so it's not a secret. You can have it on your formula card. Just want to notice sometimes they'll switch the x1 and the x2, and that's fine. So I gave it to you specifically with x2 and then x1, but on the wall it's x1, x2. It doesn't matter, and I'll show you why that doesn't matter when we do an actual example. What's this formula for? It's to find the distance between 2 points. Okay, so grab paper, let's do an example with numbers, and you'll see it's not as scary as it initially looks. Use the formula to determine the length of the line segments below. First one is giving us h at the point 1, 7, and I at the point negative 3, 5. Why h and I? It's completely irrelevant. The letters are just labeling the points. They don't mean anything in the grand scheme of things. Just for the first one, for the visual people, I'm going to start with a diagram. If you're not visual or the diagram doesn't help you, you don't need to use it. So the first point is at 1 and then 7. And the second point's at negative 3, 5. And what is the question asking us to find? So the distance between them, the length, or the shortest path from one to the other. That's what we're actually going to find, is how many units long is that distance. Formula D equals square root x2 minus x1 squared plus y2 minus y1 squared. Again, it doesn't matter the order. You can have x1 first and then x2 and then y1 and y. It doesn't matter. This is completely up to you too. Typically we take the first one and we call this x1 and y1 and x2 and y2, but you'll see in a second I can flip those and it doesn't matter. There's lots of choice for this and you'll end up getting the same answer in the end. What I'm going to do now is just direct substitution. x2 is the second x value, which is negative 3. x1 is the first x value, which is 1. y2 is the second y value, which is 5. And y1 is the first y value, which is 7. I'm going to leave a couple spaces, a couple lines, and I'm going to redo the question. I'm going to flip those numbers, and you're going to see a second what's going to happen. So I'm going to put this as the first value, and then negative 3 is the second. And then I'm going to put 7 first, and the 5 second. And we'll do the calculation, and you'll see it's the exact same answer in the end. Bed mass. What do we do first in bed mass? Brackets. I'm going to go to the brackets first. What's negative 3 minus 1? Negative 4. The second set of brackets, 5 minus 7. Five minus 7 is negative 2. And I'm just going to make a note for when you look back later. This was B of bed mass. What comes after B? Exponent. Negative 4 squared. Ooh, negative or positive? So when we square a negative, what happens? So negative 4 times negative 4, positive 16. Negative 2 squared, 4. That was the E. Now we're just going to add those together. 16 and 4, 20. We could grab our calculator. We could get the decimal value, but we don't. That's a distance. It's root of 20. We're done. That's the length between those 2 points. Okay, well, check out what's going to happen here just because I flipped the values. Brackets again, so 1 minus minus 3. Four. And 7 minus 5, 2. Now we'll do the exponent. 4 squared, 2 squared. What do we see? It's exactly the same. That's why it doesn't matter what you call y1 and y2 as long as you're consistent between the points. That's why the formula, sometimes you'll see it either way. Sometimes we'll mix up which point we use first. It doesn't matter. What it's saying is if we go from h to I, is the exact same distance if we go from I to h. Is the distance going to change just because we went in the other direction? No, that's why it doesn't matter. If we were to finish this off, we still get root of 20. So don't get too caught up over the little subscripts. Just take whatever's the first point, use it as x1, y1. Take the second point, use it as x2, y2. Let's do the second one. B, negative 110, y, negative 4, 6. Why is it b and y? Just because it is. Don't get too caught up in what they're labeling the points. What is this question asking for? What are we trying to find? The distance, the length, whatever you want to call it. Distance equals y2 minus y1 squared, or if you want to flip them, it doesn't matter. And y2 minus y1 squared. x2 is the second x, so I'm going to grab negative 4. Minus x1, which is negative 1. Why did I end up with a double negative here? Because there's a negative in the formula, and x1 is negative. So just be aware of those double negatives in a second. y2 represents the second y value, so 6. And y1 is the first y value, which is 10. Again, if you wrote this as minus 1 minus minus 4 and 10 minus 6, it's going to give you the exact same answer in the end. So don't get too caught up in the order. It's always going to be bedmass at this point. Brackets are going to come first. So within the brackets, we have minus 4 minus minus 1. Minus 3. And the second pair bracket, 6 minus 10. Negative 4. Kelston, take your earbud out, please. Note that I still have these brackets because that negative needs to be included in the squaring. If you drop the brackets, your whole answer is going to be incorrect. Now I'm doing exponents, so negative 3 squared, so negative 3 times itself. Negative 3 times negative 3. 9. And negative 4 squared, so negative 4 times itself, or negative 4 times negative 4. Yeah, 16, yes. Now we add them together, so 9 plus 16. What's the square root of 25? 5. What that means is the distance between those points happens to be 5 units on the coordinate plane. Show me your thumb so far. Good. The biggest part of this is the formula, and people get freaked out when they see these subscripts. They also get freaked out when the textbook gives it in a different way. Again, you can flip them. If you flip x1 and x2, that's fine. You just have to flip the y's as well. Okay, so don't get too caught up in the subscripts. Just go with what they mean and put them into the formula. Midpoint of a line segment is the point located, fill in the blank, halfway. So this would be the midpoint of the line segment A to B. Imagine we had 2 math tests, and your mark rested solely on those 2 math tests. If you didn't write the first one and got 0, but you wrote 100 on the second one, got it perfect, what would your final mark be? Why? Where does that come from? There was 2 tests, 0 and 100, and what do we call that when we take 2 numbers, add them together and divide? What do we call that? Think back to grade 8. We call it the average, right? So you've heard your average in the courses, whatever. Okay, what if we had 2 tests and you got 80 on the first one and 100 on the second one? What would your average be? 90, because 90 is halfway between 80 and 100. What if you got 80 on the first one and 90 on the second one? 85. So mathematically, what are we doing? Well, we're taking the numbers, adding them together, and dividing by 2. That's exactly what the midpoint formula is. MP equals Keep in mind, mathematicians were not creative people. What do you think MP stands for? Midpoint. It's a point, so it's got two pieces. It's got an x-coordinate and a y-coordinate. The x-coordinate comes from taking x1 plus x2, adding them together and dividing by 2. And the y-coordinate comes from y1 plus y2, adding them together and dividing by 2. In a second. Again, you can flip those and it doesn't matter. You could put y2 plus y1 divided by 2, x2 plus x1. It doesn't matter the order, just if you switch one, you switch the other. If you didn't add distance to your card, add them both now to your card, but at the end of today, you should now have distance and midpoint on your card. Again, it's on the wall. It's the second yellow sheet closest to the door. It'll always be up there. It's not going anywhere. Example number 2, find the midpoint between t, which is at 10.6, and s, which is at -4.4. -4, I should say. Again, I'm just going to draw the picture for the first one for visual people, because sometimes it helps you understand what we're finding. If you're not a picture person, don't worry about the picture. So the first point is at 10.6. And the second point's at -4, -4. And this time we're not finding the distance because it's not what the question is asked for. What are we finding? The midpoint. So we're going to eyeball it. Approximately halfway is here-ish. We could find the distance. It's just not what this particular question asked us. This, again, is direct substitution into the formula. Midpoint equals x1 plus x2 divided by 2. And then the y-coordinate is y1 plus y2 divided by 2. If you find the distance and then cut it in half, all that's telling you is the length of the midpoint, but it's not telling you exactly where the midpoint is. So yes, you can do that, but it's not going to help you answer this particular question. Okay, so subbing in, the first x-coordinate is the t, which is 10. The second x-coordinate is -4, and then I'm going to divide them by 2. The first y-coordinate is 6. The second y-coordinate is -4, and I'm going to divide them by 2. Because this is the first formula you've ever seen that's a coordinate point and not just a single value, sometimes for visual people it helps to box these to see them as two separate equations. If that does nothing for you, don't worry. But sometimes it's hard to see what's going on between the two. So we're just dealing with them as two separate calculations. The top goes first, so 10 minus 4, 6. And I'll do the divided by 2 in the next step. I'm just doing this step by step. And on the y side, the 6 minus 4 goes first, which is 2. Now I'm going to do the division. So what is 6 divided by 2? And 2 divided by 2? 1. So that's not a length, that's a distance, that's a location. It's the point of the midpoint. And we eyeballed it, and we're pretty dead on. So 3, 1. There's where it is. So you just might want to make a note, this is not a length, it's not a distance, it's a location. It's telling you where the midpoint is. Okay? It's a location of the midpoint. Why do we need to know this? What's the point? Well, keep in mind this unit's all about analytic geometry, which is geometry and algebra put together. So example 3 is a standard geometry question. Find the center of the circle whose diameter has endpoints f 3, 6 and g negative 2, 3. Okay, there was your read to read. Now let's read to understand. What are some keywords that we need to highlight? Well, obviously we need the points. What else do we need? So what are the geometry words behind this? Circle, definitely telling you the shape. The diameter, good geometry word there. Endpoints. And one more keyword about a circle, the center. So let's draw a picture to show what this question is asking. And now you're going to find out I cannot freehand circles. If I do them really fast, they're not bad. Well, that wasn't bad. Usually they look very egg-like. What's the diameter of a circle? What's the definition? Length across passing through the center. So let's put a dot to represent the center. It doesn't matter if it goes horizontally, if it goes vertically, if it goes on the side. We know any of the lines that passes through is going to be a diameter. How many diameters does a circle have? People always think it's 360, but could I draw one in between 2 degrees? Sure, so how many diameters does a circle have? Infinite, doesn't matter where I draw it. What they're telling us is the 2 endpoints of the circle. One is F, one is G, it doesn't matter which one goes on the left and which one goes on the right. We just know one is F and one is G. We're told that F is at 3, 6, and G is at negative 2, 3. So I could have chosen to plot this on a coordinate plane. It's just not necessary to do the question. But if that makes more sense to you to actually plot the points, draw a circle, then do that. Trickiest thing with these is just trying to figure out, are we using distance or are we using midpoint? So is it asking for the length of something, or is it asking the location of something? The location. So if it's asking a location, which are the formulas? Midpoint. If it's asking a length or a distance, that's going to be the distance formula. What is it asking the location of? The center. And what do we know about the center on the diameter? It's the midpoint. So all this question is asking for is the midpoint. Formula is MP equals, Kelston, that's really distracting. It's so shiny and pretty. x1 plus x2 divided by 2. y1 plus y2 divided by 2. Again, don't get too caught up in this little subscript 1 and 2. All it means is we're taking the x values and adding them together and dividing by 2. It doesn't matter which one you write first. So I'm going to write 3 and then minus 2. I could have written minus 2 plus 3. It doesn't matter the order in these. I'm going to do the same with the y's. I'm going to write 6 and then plus 3. Again, sometimes for visual people, circling them just helps you keep in mind we're doing 2 little calculations here. Numerator goes first, so 3 minus 2 is. And the second one, 6 plus 3 is. Can we divide them by 2 evenly? So can I divide 1 by 2 and 9 by 2? So what do? How can I divide them evenly? Yeah, this is at 0.5 and 4.5. That's the location. It's half a unit over, 4.5 units up. So if you can't divide, no big deal. It just means it's in between boxes. Just repeating, how did we know we were using midpoint formula? Why didn't we use distance formula? Because it was a location, not a distance. If it said find the length of something, we would be using distance formula. Number 4, read to read. Keywords, what would you like to highlight? Midpoint. Line segment. Oh, I think we got that. Start with a picture. What's a line segment? It's a line. Well, it's kind of a line. What's the difference between a line segment and a line? Line segments end, lines go on forever. What are the letters of this line segment? N and O. Does it matter which way I put them? No, I could have put O on the other side and N on the other. Right, doesn't matter as long as there's an N and there's an O. Okay, what else do we know? We know the midpoint. What's its value? What else do we know? Point N is -4 and -10. What do we not know? O. So this is a working backwards one. So this time we're given the midpoint. We don't have one of the endpoints. We're going to use the formula because it's all we have for midpoint. Okay, so let's sub in what we know just like before. I have the first x value, which is -4. Do I have the second x value? No, so I'm just going to leave it as x2. I have the first y value, it's -10. Do I have the second y value? No, so I'm going to leave it as y2. What am I going to do with this -5, 1? Put it where MP goes, because that's the answer. We know that it's equal to -5, 1. Here's a really common mistake. People are going to say, well, -4 is x1 and -5 is x2, and they're going to add them together and divide by 2, and then take the -10 and 1 and add them together. Why is that incorrect? What would that find? The midpoint of this little section. Is that what the question is asked for? No, so I'm not just taking them and adding them together. I have to work backwards. What we're going to do is equate the sides. I know that -5 is equal to this half of the equation because it's the x-coordinate. I know that 1 is equal to this part of the formula because it's the y-coordinate. So what I'm going to do is just make two little formulas out of them. I know -5 came from taking -4, adding x2, and dividing by 2. I know that 1 came from taking -10, adding y2 and dividing by 2. All I need to do now is work backwards. These now just become little tiny linear equations. We want to isolate the variable. What's the opposite of dividing something by 2? Timesing by 2. So on the left-hand side, I get 2 times -5, which is -10. On the right-hand side, the 2's cancel, so I'm left with -4 plus x2. How do I get rid of this -4? How do I move it to the other side? +4. So -10 plus 4 minus 6 equals, on the right, x squared, x2 we call it. What did I just calculate? What did I just find? The x-coordinate of this guy. I got to do the same thing for y. What's the opposite of dividing something by 2? Timesing by 2. So he's going to come up and be multiplied. How do I get rid of the -10? Add it. So y2 equals 12. So what are the coordinates of O? -6 and 12. This is a working backwards one. For the first part of this unit,